talk about Chapter 3, Section 3, using function notation to evaluate and interpret. So for review, we're going to evaluate a linear function. For example, let's say we have here for f of x equals to 2x plus 5. Find the value of f of x when x is equal to negative 1. So the first step to doing this is I know that we're looking for x. So in my formula, I have f of x equals to 2x plus 5. What I want to be changing here is my x variable. And so I get f of negative 1 equals to 2 of negative 1 plus 5. And so all I need to do now is just solve for the expression. So 2 times negative 1 gives me negative 2. And then I drop down the 5. And so negative 2 plus 5 just gives me positive 3. And so I know now that f of negative 1 equals to positive 3. And that would be my answer. Alright, let's try the next one here. So solving for an independent variable is going to be a little different. And the reason why is, for example, if we have here for h of x 2 over 3x minus 5, find the value of x when h of x is equal to negative 7. This time I have each of x, not just x. And because of that, it's going to be a little different when I write it down. So if I have the equation here, h of x equals to 2 over 3x minus 5, instead of just substituting the x, what I'm going to do is I'm substituting the entire h of x, because that's what it's telling me right here. It's telling me that the entire h of x is going to be substituted for negative 7. So here I'm going to write down negative 7 equals to 2 over 3x minus 5. And so now all I'm going to do is just solve for the x. So when I do that, I get, let's see, I add 5 on both sides, and then I'm left with negative 2 equals to 2 over 3x. After I do that, I want to divide 2 over 3 on both sides. So I'm going to divide 2 over 3 on both sides. These two cancel out. This is kind of ugly, so I want to make it look nicer. So over here, I'm going to write down negative 2 divided by 2 over 3 equals 2x. I can change that format to negative 2 divided by 2 over 3 equaling to x. And I know that if I'm going to divide a fraction, I need to change my division sign to multiplication, and I also need to flip the fraction to 3 over 2 instead. So now I'm left with negative 2 times 3 over 2. I know that negative 2 as a whole number is just negative 2 over 1. And so I can just solve it this way, where negative 2 times 3 gives me negative 6. 1 times 2 gives me 2. And so negative 6 divided by 2, I can simplify that to negative 3. And so my answer for x would be negative 3. Alright, so let's try it out. Let me clear my screen. Okay, so over here it says evaluate the function b of x equals 3 minus 6x when x is equal to negative 2. So I'll give you a few seconds to do this. Alright, so let's try it out. We have here b of x equals to 3 minus 6x when x is equal to negative 2. Now, since we are looking at only x, that means that we're only substituting the x variable here. So I'm going to get b of negative 2 equals to 3 minus 6 times negative 2. And we want to make sure to have those parentheses because that differentiates the negative 6 minus 2 to the negative 6 times negative 2. And so all I need to do now is just solve. So right here, I can combine the negative 6 times negative 2, and that gives me positive 12. Then 3 plus 12 just gives me positive 15. And so my answer for b of negative 2 is 15. Let me clear it, and then let's try out the next one. So the next problem here is asking us to evaluate the function b of x when it's equal to 6x plus 9 when b of x equals to 21. So I'll give you again a few seconds to answer this as well. Okay, cool. Let's try it out. So I'm going to write down the equation again. B of x equals to 6x plus 9 when b of x equals to 21. Now this time we are looking at b of x, the whole thing, rather than just x. And so I'm going to substitute b of x for 21. And I get 21 is equal to 6x plus 9. And so the last thing I need to do is just solve for x. So I'm going to subtract 9 on both sides. When I do that, I get 10. This changes to a 1. So 10 minus 9 gives me 1. Drop down the other one. And then I'm left with... Is that true? Am I doing this correctly? I'm not. I am not doing it correctly. Oops. That does not turn into a 10. That actually turns into an 11. And so because that turns into 11, that turns into a 2. Yeah, that makes more sense. Alright, so I have 12 here, and I drop down the 6x. Now the last thing to do is just divide 6 on both sides. So I'm going to divide 6 on both sides, and when I do that, 12 divided by 6 gives me 2. And these two cancel out, so I'm left with x equaling to 2. Let's move on with the content. So we're also going to learn how to graph linear functions. When we're graphing for f of x equaling to 2x plus 5, what I like to do is I like to use 5 easy numbers. And the 5 easy numbers are usually negative 2, negative 1, 0, 1, and 2. I only want to find points that will make my image easier to draw. So I want to go with smaller numbers. And the smallest numbers I can find are negative 2, negative 1, 0, 1, and 2. So the way that I write it down is I see here that x is equal to negative 2. Now I want to do what I've been doing, which is substituting the x into my equation. So I'm going to have here f of negative 2 equal to 2 times negative 2 plus 5. When I solve for that, I get negative 4 plus 5, and negative 4 plus 5 just gives me positive 1. Then after I find this number, I'm going to place that where it belongs with the f of negative 2, and so that goes down here. Now the next one that I'm going to do is x equals to negative 1. And I have here f of negative 1, which is 2 times negative 1 plus 5. 2 times negative 1 gives me negative 2 plus 5. That gives me positive 3. So my output here would be 3. And that's only when x is equal to negative 1. Let's try the next one where we have x is equal to 0. If f of x is equal to 0, then we get f of 0 equals to 2 times 0 plus 5. That equals to 0 plus 5, and that's just 5 in the end. So when x is equal to 0, I know that my output would be 5. X equals to 1, let's change that. We have f of 1 equaling to 2 times positive 1 plus 5. That equals to 2 plus 5, and that's just 7. So whenever x is equal to 1, I get the output 7. And the last one is x equals to 2. In this case, f of 2 is equal to 2 times 2 plus 5. That's 4 plus 5, and that equals to 9. So whenever x is equal to 2, I get 9 as my output. Now that I have all of my inputs and outputs, all I need to do now is just write them as ordered pairs. We always say that this is our domain. X is the domain, and f of x is our range. So if I write the ordered pairs, I get negative 2 and 1 for my first one here. And then I have here negative 1 and 3. I get 0 paired up with 5. 1 is paired up with 7. And 2 is paired up with 9. And all I want to do now is just graph it. So I'm going to draw a line down here and then draw another line over here. And then I'm going to go by 2 since I don't have much room. So 2, 4, 6, 8, and 10. On the other side I have negative 2, negative 4, negative 6, negative 8, negative 10, positive 2, positive 4, positive 6, positive, oops, not 7. Let me go back on that. That was positive 8, positive 10. And the last one here is negative 2. I can switch that in. Negative 4, negative 6. It's positive 6. Negative 6, negative 8, and negative 10. And then now I'm just going to pair it. So I know that the first one, it says to move to negative 2. So I'm going to move to negative 2 and go up to 1, which is right here. The next one says to go to negative 1 and then go up to 3. So starting at negative 1, I go up to 3. The other one says that we stay at 0 and we're going up to 5, which is right here. The next one says to go to positive 1 and then go up to 7. And the last one over here says to 9, so going to 2 and going all the way up to 9. And so as you can see here, we form this linear image, which is just a line being shown. Okay. So let's try it out. Let's say right here, we're asked to fill in the table for f of x when it equals to negative 2x plus 1. So I'll give you a few seconds to do that. Alright, cool. So if I'm going to solve for x equaling to negative 2, when x equals to negative 2, I get here f of negative 2 equals to not 2, but negative 2, since it did have that negative 2 next to it. Negative 2 times negative 2 plus 1. Negative 2 times negative 2 gives me positive 4 plus 1 equals to 5. Then I have here let me write down that that was the output for -2. Then x equals to -1 is f of -1 equals to -2 times -1 plus 1. That equals to +2 plus 1, which is +3. So the output for -1 is +3. I have here x equals to 0, and that is f of 0 equals to -2 times 0 plus 1. That's just 0 plus 1, and that equals to 1. So the output for 0 is 1. X equals to +1 would be f of 1 equals to -2 times 1 plus 1, and that's just -2 plus 1, which is -1. So the output of +1 is -1. And then the last one we have here is x is equal to +2. So f of 2 equals to -2 times +2 plus 1, which is -4 plus 1, and that equals to -3. And that would be my last output for this table. So hopefully this helps. Good luck.